Now, before we work this out, I want to just make sure that you can see how to proceed. So if you read through the problem, you can notice the last sentence here. We're interested in testing the hypothesis that these two means are equal. This is the key line. It's talking about means, so you know you need to work with the t-distribution. It's talking about not just means, but it's actually talking about two means. So you know you need to use the two sample problem setup, and you're asking, are they equal or not? So those are kind of the three words that tip this off. Let's run through the process. First thing you should do is do step 0 and compute the test statistics. I guess I should label, I'm calling this population 1 and population 2. So you can use Excel or whatever you want for that. Step 1, I want to compute the null and the alternative hypothesis. So if nothing is going on, then the two means are equal. The presence of these weeds doesn't change the yield. If something is going on, then they're not equal. That's what we want to study here, equals, not equals. Step 2, I want to compute the t-statistic. So I'm going to write down my first mean, 162.83, subtract 157.6, and I want to divide this by the standard deviation, 4.469. You want to square that divided by the first sample size. Well, that's just 4. The second standard deviation, you want to square that, divide by 4 as well. All that's under the square root there. When you do this, you should get 5.23. So there's your statistic. Now you want to compute the probability, the p-value. So the p-value is the probability, it's actually 2 times the probability that t take the smaller of the two sample sizes, -1, they're both 4, so 4 minus 1 is 3. Probability that the t-distribution with 3 degrees of freedom is greater than or equal to 5.23. And when you run this, you should get 0.41482. And so then step 4, you would definitely want to fail to reject the null hypothesis. And so the point is, the data gives no evidence that the means differ. So it may well be that the means do differ, but this data gives 0 evidence of that. I mean, it's a huge p-value.